Today we will be learning percent composition. The percent composition of a compound is a relative measure of the mass of each different element present in the compound. Step 1. Calculate the molar mass, m, of the compound. Step 2. Calculate the total mass of each element in the formula of the compound. The mass of the element present in 1 mole of the compound. Step 3. Calculate the percent composition. Percent by weight, aka mass, of element is equal to total mass of each element divided by molar mass times 100. It should look like this. Now, for an example, we will calculate the percent composition of carbon. Finding the molar mass. Step 1. There is only 1 carbon in the compound, and you can find the molar mass on the periodic table. So it says 12.01 for carbon, and it has 2 multiplied to the 16 grams because there's 2 oxygen elements, and it comes out to 44.01 grams per mole. And from the molar mass, we know now that carbon is 12.01 grams per mole. So now we find the percent composition of carbon, like in step 3, and it's part over total times 100. So the part is carbon, 12.01 grams per mole, over total, 44.01 grams per mole, times 100, and we get 27.29%. A related note, let's do some empirical formulas. Now we are going to determine the empirical formula for the following compound. So we are going to start with the number of grams of each element given in the problem. If percentages are given, assume that the total mass is 100 grams so that the mass of each element is equal to the percent given. So pretty much instead of there being a percent sign there, just change it to grams. Now we will convert the mass of each element to moles using the molar mass from the periodic table. So on the board it says PT, that stands for periodic table. So what's given? The grams, the 57.14 grams carbon times 1 mole C divided by 12.01 grams of carbon. So what is on the periodic table? And that will get you 4.76 moles of C. And we repeat for the bottom ones. So what is given? 6.16 grams hydrogen. And yeah, so we pretty much convert it to moles. Don't forget to cross out the gram signs, as you can see. So like for each one, the grams for carbon, grams for hydrogen, grams for... Now we will divide each mole value by the smallest number of moles calculated, and we will round to the nearest whole number. As you can see, there is 2.5, and that's too in between to really round, so we will have to take another step. So we will now multiply each solution by the same factor to get the lowest whole number multiple. So now 2.5 is in a whole number. Now we have the empirical formula.
Go ahead.